Hi students, in this video we are going to explain about mapping functions. We know that the processor will request from memory certain words by specifying its address through address lines. These words will be first checked inside the cache memory. Suppose that the word is present in cache memory, it will be forwarded to the processor. Otherwise, suppose if the data or that is the required data is not inside the cache memory, the data will be taken from the main memory, it will be copied to the cache memory, and then the data will be forwarded to the processor. And we also know that the cache memory is divided into equal size blocks. What is the meaning of a block or a cache block? It is contiguous address locations which will be of fixed size is called a block. Main memory is also divided into blocks. That is, the size of one block in main memory will be same as the block size in cache memory. So initially all the data will be inside the main memory. As per request, the corresponding block containing the word will be taken from main memory to cache memory. That is, a mapping function or a correspondence between the main memory and the cache memory is specified by mapping function. One more point is that the size of the cache memory is less when compared to the main memory. That is, it can only store less number of blocks, but the main memory capacity will be very huge. So whenever we want to take any block from main memory to cache memory, we have to decide at which cache block that corresponding main memory block will be stored, and that is based on mapping functions. Here we have to study three major or three popular mapping functions. The first one is called direct mapping. The second mapping function is called associative mapping, and the third one is called set associative mapping. In order to explain all these examples, we are considering one example problem. And here we can see that in my example, suppose this is the cache memory. The cache memory contains 128 blocks. So I am numbering the blocks. This is the block 0, this is the block 1, etc., etc. This is the last block, that is block 127. Since I am starting from 0, the last number will be 127. So in my example, I considered that the cache memory has 128 blocks. And we can also see that each block contains 16 words. That is, 0th block contains 16 words, next block contains 16 words, like that. So if you take any block, its size is 16 words. So this is the information regarding the cache memory. Now we are going to explain the main memory. Suppose that the main memory has 4096 blocks. So you can just imagine, or you can just compare the size of the cache memory and main memory. So this is one example I am taking. So I took a cache memory which contains 128 blocks. Each block has 16 words, and I took one main memory which has 4096 blocks are there, and the size of one block is same, that is 16 words. That is, block size of main memory and block size of cache memory are same. So if you want to know the total capacity of the cache memory, what is the equation, or how you can calculate the total capacity of cache memory in this example? 128 blocks are there total. Each blocks are of size 16 words. So I'm just multiplying 128 into 16. That means Total 128 blocks are there in my cache memory and each block has 16 words. So the total, if you multiply those two values, you will get 2048. So we can write 2048 as 2 into 1024. We know that 2 we will write as it is. 1024 is same as 1 kilobyte. So we will get 2 kilobyte. So that is the capacity of the cache memory. And here I explained how you took the 2 kilobyte. That is the capacity of the cache memory as 2 kilobyte. Total 128 blocks in the cache memory. Each block has 16 words. So if you multiply those two values, you will get 2048, which is same as 2 into 1024. We know that 1024 is 1 kilobyte, that is 2 to the power 10. It is 1 kilobyte and the 2 we are writing as it is. So 2 kilobyte. 2 into 1 kilobyte is equal to 2 kilobyte. Then if you want to calculate in the same manner, if you want to calculate the total capacity of the main memory in our example, that is in the same manner, 4096 blocks are there. Each block has the capacity 16 words. So if you want to calculate the total capacity of the main memory, total 4096 blocks are there. Each of them has the capacity 16 words. So if you multiply 4096 into 16, you will get 65,536. And if you want to know how much kilobyte, you just divide it with 1024. That will give you 64. So the total capacity of the main memory is 64 kilobyte. So the same question may appear for the external examination. So you first of all, you understand that what is the capacity of the cache memory in our example and what is the total capacity of main memory in our example. So we took 2K size cache memory and which contains 128 blocks, each block containing 16 words. In the case of main memory, 64 kilobyte main memory is there, which is divided into 4096 blocks, each block having 16 words. So that is the details about my example. So the next we have to consider is that, so same thing is written here. I just took in my own way to explain this example. So suppose that a cache memory which consists of 128 blocks, 16 words each. So total 2048, as I said, 2 into 1024 is equal to 2 kilobyte words are there. That is the case of cache memory. And so I'm writing in detail how you got this value. Then we have the main memory which contains 64 kilobyte words. And we can view this as 4 kilobyte blocks. 4 kilobyte means 4096 blocks of 16 words each. So the total capacity is 4 kilobyte is equal to 4 into 1024 is equal to 4096 words are there. So if you want to calculate the total capacity, I said that how you got 64K, 4096 blocks, each blocks contains 16 words. If you multiply both the value, you will get 65,000 something value. Which divided by 1024 will give you 64. So the total capacity of the main memory is 64 kilobyte. And suppose if you know all these values, that is we know the capacity of the cache memory and the capacity of the main memory. The first thing we have to know is that what will be the total number of lines, total number of bits in address lines. That is how many total address lines will be there. We know that the main memory capacity, as we said, is 64 kilobyte. So I am splitting the value 64 kilobyte is equal to 64 into 1 kilobyte. You know that 64 is 2 to the power 6 plus 1 kilobyte, into 1 kilobyte is 2 to the power 10. So you will get 2 to the power 16. So how many address lines are needed for this memory? In order to access any word from the memory, 16 address lines are required. So these are the basic things. And we are taking this example in order to explain 3 mapping functions. Okay. The first method we are going to explain is called direct mapping. We already said that there are 3 different mapping functions are there. Here we said that what is a mapping function? Mapping function means the correspondence between the cache memory and the main memory. That is, we will have a dilemma if you want to access a particular block from main memory to cache, where we will store inside the cache. There are a lot of blocks are there. Okay, so based on certain rules, we will decide where we have to store one main memory block inside the cache memory block. And that are based on the three different functions which are called mapping functions. And as we said, there are the first one is called direct mapping, the second one is called associative mapping, and the third one is called set associative mapping. So based on the example, we are going to explain the first type of mapping, that is called direct mapping. The idea of direct mapping is very simple. Here, we based on our example, we will specify how the direct mapping works. And we said that in our main memory has 4096 blocks are there. The cache memory contains 128 blocks are there. Suppose that we have to map jth block of main memory into a particular cache memory block. We just want to do this calculation. That means that block J of main memory can be mapped on block J modulo 128 of cache. Okay, so based on this example, I am explaining this concept, direct mapping. In the case of direct mapping, suppose J is a block in main memory. In our example, suppose 128 blocks are there in cache. If we want to decide in which cache block the block J will reside, or we will place the block J of main memory, that can be calculated based on this equation. Block J of main memory can be placed on or placed inside block J modulo 128 of cache. And how you got this 128 value? Because in our example, the cache memory has 128 blocks are there. So certain examples we can take. Suppose that we have a block 0 in main memory. That is, we want to decide where we will place the block 0 of main memory in cache. So here the value of J is equal to 0. That is, we want to move block 0 main memory block. So we want to write this equation as J modulo 128. So what will be the value J mod 128? We will get the remainder. 0 mod 128 is equal to 0 itself. That means where we will store the 0th block of main memory, that will be placed on block 0 of cache. So for an example, second example, we can take J is equal to 1. That is, suppose that we are taking the second block of main memory. That is block 1 of main memory. Here the J value will be 1. So where we will place the corresponding main memory block? If you want to find out the result, we just want to execute, or we want to write this equation 1 modulo 128. Here 1 means the main memory block number. 128 means the total capacity of or the total blocks in cache memory. So 1 mod 128, which is equal to 1. So that means that the first block of main memory will be stored in first block of cache memory. So in that manner, we can give different values of J. We just want to apply the corresponding J value. We just want to change the values in J value, and its result, the equation's result will give you the corresponding cache number where the appropriate J block in main memory will be stored. So if you're continuing this process, we can see that which means that the main memory blocks numbered 0, 128, 256, etc. will be loaded at block 0. That is cache block 0. That means the 0 mod 128 gives 0, 128 mod 128 gives 0, 256 mod 128 gives 0. So the result of all this, if the J value is 0, 128, 256, 512, etc., it goes. And if we divide the corresponding value of J with 128, we will get the result 0. That means all these main memory blocks will be loaded at cache block 0. In the same manner, the main memory block number 1, 129, 257, etc. can be loaded. That can be only loaded at the cache block 1. So that is the style of performing the mapping. So these are the way how the mapping, the direct mapping method works. So the common idea is that suppose we are taking jth block of main memory. If 128, that is based on the example we are working, if 128 is the total capacity or the total number of blocks in the cache, then if you want to know in which cache block we will place the jth block of main memory, which can be calculated by using the function, using the equation j mod 128. So that result, the result of that equation will give you. So that is a way how to find out or how, that is a way of direct mapping. And here we know that in our example total 16 address lines are there, because total memory capacity as we said is 64 kilobyte. That means 16 address lines are needed by the processor in order to specify the address. Next we have to explain is how this address lines are divided. A memory address is divided into 3 fields. That is in the case of direct mapping. The memory address, that is in our example the total memory address is 16 bits, which is divided into 3 parts. The first part, in this example, here the values are based on our example. So common thing is that the memory address is divided in direct mapping into 3 separate fields. The first field, the most significant bits represent, certain most significant bits represent the tag field, then comes the block field, and then comes the word field. So tag, block, word. So these are the 3 different fields. In the case of direct mapping, the memory address is divided into 3 fields. So we want to find out how we will get these values. Here the meaning of the word is that, the meaning of word means we know that the processor may require a word which is inside any one of the block. So in our example, each block has 16 words each. 16 is equal to 2 to the power 4. That is why the least significant 4 bits will specify the words based on our example. So the actual meaning of word is that which word inside that block is our required word. If you want to decide how many bits are used by the word, this field, in our example, each 16 words are there in one block. 16 words, the value 16 is equal to 2 to the power 4. So 4 bits are required in order to specify the corresponding word. 4 bits are used for that field. Then next one is called the block field. Block field means which cache memory block contains our required data or required word. That is meant by the block field. And the most significant tag field is that we know that we are using direct mapping, and as we said in cache block 0, there are a lot of choices are there. Either it may be main memory block 0 or the content may be main memory block 128. So like that a lot of possibilities are there. That is, they can only be mapped to block number 0. So which one resides in block 0? Or not block 0, in that particular block. So if you are taking this example, if we are taking block number 0 of cache, either 0 of main memory will be there, or 128th block of main memory will be there, or it may be the 256th block. So like that 32 combinations are there. Any one of the 32 block can be reside in the block 0. So which corresponding main memory block resides in that cache memory block, that is indicated by the tag field. And this is the way how to find out each values. That is, the first part will give you the word, number of bits required into a word field, The next one will give you the number of bits used for block field, and this part will give you the total number of bits which are in tag field. So as I said, in our example, total 16 address lines are there. We have to divide the 16 address lines in direct mapping into 3 different fields. The first one is word field. The least significant certain bits are used for word field. Then comes the block field. Then comes the tag field. So as I said, how you will get the word field? In order to find out the word field, first of all, we have to check how many words are there in one block. 16 words are there in one block. And how can you write the 16? 16 is equal to 2 to the power 4. So this power value will give you the number of bits needed for the word field. The next field we have to explain is called the tag field. Here as a block field. We want to find out how we will get this value 7. We know that total 128 blocks are there in our example in the case of a cache, and 128 is equal to 2 to the power 7, and this power will give you the number of bits needed for specifying the block. That is the second one. So thus we got the value 7 here. That is total number of blocks in cache memory is 128. That is equal to 2 to the power 7, and that power we will write as block. That is the 7 bits are needed to specify the block. That is which cache block contains our required data. The next part is the most significant bits are used for specifying tag, and how you will get the tag field. In order to specify the tag field, we know that 4096 total blocks are there in main memory, and in the case of cache memory only 128 total blocks are there. So we just want to divide 4096 divided by 128, then we will get 32, and 32 is equal to 2 to the power 5. So 5 bits, the higher order 5 bits will specify the block. It is used as the tag bit, tag field. And what is the use of the tag field? As I said, in our example, the block 0 of memory, here we can see that. Here, this is the figure, the cache memory. In our example, 4096 main memory is there. So in the case of direct mapping, which all blocks can be mapped to block 0 of cache, either block 0 or block 128 or block 256. So all can only be mapped to 0. That is, if you want a block 0 of a main memory, it can be stored in block 0 of cache, because 0 mod 128 is equal to 0. Suppose if you want to store 128th block of main memory to cache, where we will store? For that we have to execute that function 128 mod 128, that is equal to 0, which means that the block 128 of main memory, if you want to store in cache, that can be only mapped to block 0. So like that, 32 such blocks can be, if you are executing that mapping function, 32 main memory blocks can be mapped to this cache memory. That is, in block 0, the main memory block can be either block 0 or block 128 or block 256, like that. So such 32 blocks can be mapped to block 0. So that 32 value we got from this tag field. So 4096 divided by 128, which means that total 4096 main memory blocks are there, 128 cache memory blocks are there. When we divide the values, we will get 32, that is equal to 2 to the power 5. That means that 5 bits are needed for tag fields. And as I said, the tag bits will identify which of the 32 main memory blocks mapped into the cache position currently resides in that cache. That is, at that time, which main memory block, that is, which of the 32 main memory block resides in the cache memory block. So that is the meaning of direct mapping. So this is the basic idea of direct mapping. Block J of main memory can be mapped to block J modulo 128. This is not the common case. Based on the example, I am explaining the direct mapping. So if you are in that case, all these 32 different main memory block can be mapped to block 0. All these 32 main memory blocks can be mapped to block 1. So like that. So in the case, if we have 16, that is based on our example, we have 16 address lines are there. How we got the 16? We know that the total memory capacity, main memory capacity is 64 kilobyte, which is equal to 2 to the power 16. And in the case of direct mapping, the 16 address lines are divided into 3 different fields. The lower order bits will specify the word, that is which word of that block is our required word. Then comes the block field, that is which cache memory block contains our data. Then comes the tag field, that is which of the 32 main memory block is there inside that particular cache location. That are the 3 different fields needed for direct mapping. In order to explain these values, the first thing is that how we will get the word field as 4. So in our example, we know that each block contains 16 words. 16 is equal to 2 to the power 4. So 4 bits are needed for the word field. And if you want to know, know the next field, that is the block field, how we will get the value. Total number of blocks in cache is 128, that is equal to the power 7. So 7 bits are needed for block field. Then comes the tag field. So in order to get the tag field, we have to divide the total number of blocks in main memory divided by total number of blocks in cache memory, and we represent the value as power of 2. So that power value will give you total number of bits which are needed for specifying the tag. Next is, what are the advantages and disadvantages of direct mapping? The advantage of direct mapping is it is very easy to implement. But the drawback is that contention, and it is not flexible. That means that, suppose that the cache memory block is free now, and suppose the processor wants a word which is inside the block 0 of main memory. As per the rule, the block 0 of main memory will be stored inside block 0 of cache, because 0 mod 128 is equal to 0. So we can only store block 0 of main memory inside block 0 of cache. And suppose that the processor requested for a word which is in 128. So based on our direct mapping method, the block 128 of main memory can only be stored in block 0, which is already occupied. Actually, there are free blocks are there inside the cache. Since we are using the rule, if you want to store 128th block, we want to remove the values inside this block, and we want to store the new block here. So that is the meaning of contention. Contention means maybe the cache memory may contain some free blocks. Since we can store the main memory block into certain cache memory block. That is, it is only possible to store certain main memory blocks in certain fixed cache memory block. It is very rigid. So that is why that is the main problem in the case of direct mapping. That is, it is not flexible and contention problem will be there. So these are about the direct mapping method.